Good morning. It's 7:30 a.m. here at Dodge Hall at Oakland University. Today we're punching tubes with the latest Goodway tube punching machine. I'll show you how we punch this absorber out. This is a 350-ton absorber, or is it, I think it's 450-ton cooling absorber using sodium and high temp hot water to cool the building. Actually, to cool several buildings. And I kind of went the wrong way. People making me nervous. So this is punching the tubes. You step on the foot pedal, feeds the line in. It automatically stops on its limit at the distance I want. Now we're going in reverse, and it's coming out 1,000, 2,000, 3,000, 4,000. We're going again for another tube. And it feeds forward, going about 20 feet into the machine. And we're reversing. And the reason you punch your tubes is for high efficiency cooling. You want your machine to be as efficient as possible, so it removes any contaminants, sludge, rust out of the chill. This is the condenser water coils. The condenser water is this tube bundle on the bottom. The evaporator is on top, and high temp hot water reacts with the sodium to give us your cooling. Here are your different settings. We're not on now, so we're not getting much temperature. 91. You'd normally be at 245 degrees from our high temp hot water plant. These are our condenser pumps that go out to the cooling tower and remove the heat from the building. These are our chill water pumps that take the cooling from the absorber and bring it to the air machines. We have, this is a horizontal pump, H-style, Aurora pump division. The bearings are a little trickier on that one to change than your typical Taco. Here are more chilled water pumps going to various air machines. These are your air machines that take the hot and cold water and heat or cool the building. So right now we have heating supply. We're in winter. We're heating. We're at 70 degrees temperature on our heating supply. Our heating return, we're only at 70. So this machine is not really putting out much heat. I don't think the heating valve's even open right now. It's about 50 degrees outside. Then you have your chill water loop. This is going to be your air machine. We'll take a quick look inside. Inside you get a mixture of full fresh air, return air, and supply air. Here you're supplying, there's a set of chill water coils right here. And behind that set is your set of hot water coils. This is your very large fan with very large bearings. Here are the bearings. Pillow blocks with, looks like a 4-inch shaft. Here's about a 75 horsepower motor working away day and night. 4 belts. Large pillow block again, 4 or 5 inches. Doing a lot of hard work. And bearings Need grease, so there's a little grease cap on top. I don't know if you can see that. It's a pretty large room for an air machine. Here's your grease cap on top. Trying to get some into the fan. There's quite a fan, quite the thing to be. Here's our condensate return. Comes from the pan and out there, and you lose all your humidity out of the building this way. And that's a quick tour of Dodge Hall at Oakland University. Compressor pumps to run the thermostats, dampers, pistons for chill water, hot water, return supply, air dampers. There's our water feed tank for the system. You put the glycol in there, and this blue glycol creates a cushion of pressure with the ethylene glycol we insert here in this barrel. And once the barrel is full of ethylene glycol, it holds the pressure at 15 pounds or so on the system. And this is our chemical feed to treat the water in the cooling tower up on the roof. But it adds chemical to keep away Legionnaires. And it's constantly monitored by our technicians. Our chemical feed pump to trace our system. It has a light in here, phosphorescent, and it can tell when you need your 3D tracer installed or added to the system. It'll automatically add 3D tracer and adjust it for us. The chlorine we have to adjust, so we take readings up here on our system operating data. So we have the 3DT265, which is your tracer, and you have your different pumps. You go to action pumps, and you can add I don't want you to catch on to our secret code here, but you add on the SD70, and that's where you're able to control the biocides and everything else you might need. System performance, select information, operating data. That's the most important, keeps us up to date. We monitor our conductivity, especially keep it at a certain 1100 to keep down contaminants. And again, that's our big absorber, 450 ton. It cools more than just this building on campus, but a few. Our Science and Engineering building, Hanna building, and Dodge Hall. Hope you enjoyed this presentation, and have a good day.